Okay, so we've gone through power passing devices. We've shown you a simple on-off switch. We've shown you a couple of relays, and we've even translated into some things you might see in the field by showing you a high-pressure cutout switch. Now we're going to talk about the contactor. The contactor is a lot like your relay, but the difference is that number one, a contactor usually is used with higher voltages. And number two, instead of cutting one leg of your power like you do on your relay, where you're just cutting the hot side of your power and having it come in and go out, with a contactor, you're supplying both your hot and your neutral to one side, and when the coil is activated and sucks down, both your hot and your neutral come out the other side and supply a load of some sort. Now your on-off switch is going to be on the side, your 24 volts. So whereas before we showed your on-off switch for your relay, where your 24 volts was down here on the relay, on a contactor it's going to be on the sides, and it's even colored differently. You have silver contacts over here for your 24 volts, copper contacts on both sides of the contactor for your 120, or your hot and your neutral. So the way you would test a contactor would be much like the way you test a relay, with only a slight variation. So you would test the sides of the contactor to make sure you have 24. And if you have 24 volts, then your coil should be sucking in or pulling in. And then you could test on the incoming side of your contactor to make sure you have 120 volts. And if you do, then you can test on this side of the contactor and see if you have 120 volts. And if you don't, then you know you've got a problem with your coil, because if your contactor is pulled in, or even if it's not pulled in and you still got 24 volts here, you should be getting power on the other side, on the outgoing side of your contactor. This would be your incoming side, just like this is your incoming side on your switch. This is your outgoing side, just like this is your outgoing side on your switch. And power passes from one side, 120 volts passes from one side to the other side. And your on-off switch, which is your 24 volts, is pulling this coil down and allowing the volts to pass through and go to a load of some sort, whether that load be a compressor, a fan motor. There will be a load that voltage is supplying so that it can run, a power consuming device that needs to run off that voltage that is passing through. So that's the biggest difference, is the fact that you're not splitting one leg of the power and coming in and going out. You're taking both legs of the power and going in, and both legs of the power are going out, and your control voltage is on the side. A lot of students forget where the control voltage comes in and out, or goes to, I shouldn't say goes in and out, but is supplied to, and they end up putting it over here, or they end up putting 120 volts here. And that obviously isn't going to work, and you can also fry the contactor by supplying too much voltage to your 24 volt side. So hopefully that helps explain that a little better, and makes a little more sense to you than it did to begin with.